Bismillahirrahmanirrahim. My name is Dr. Rida Sharam Sarwar, and under my supervisor, Dr. Saira Afzal, today I will be presenting the chi-square test. Quote of the day is a person who never made a mistake, never tried anything new. The learning outline. What is basically a chi-square test? Important terms and characteristics. Formula and how to perform chi-square test by hand. Chi-square distribution, p-value, properties, worked examples, when to use a chi-square test. There's two main types of chi-square tests with some details about independence and goodness of fit, limitations, recent advances, as well as MCQs. The learning outcome. At the end of the presentation, participants would be aware of the basic terminologies of the chi-square test, their uses, applications, properties, and limitations of the test. They will also have learned how to perform the test by hand and draw inferences about accepting or rejecting their hypothesis based on the values that they've calculated. What is the chi-square test? So the chi-square test is a statistical procedure for determining the difference between observed and expected data. This test can also be used to determine whether it correlates to the categorical variables in our data. It helps to find out whether a difference between the two categorical variables is due to chance or due to a relationship between them. The chi-square test is an important test among several other tests of significance developed by statisticians. It was developed by Karl Pearson in 1900s, and it is basically a non-parametric test, which means that it's not based on any assumption or distribution of a variable. This statistical test follows a specific distribution known as the chi-square distribution. In general, the test we use to measure the differences between what is observed and what is expected according to an assumed hypothesis, which is called the chi-square test. Important characteristics of the test are that firstly, it's a non-parametric test and it's based on frequencies and not on parameters like mean and standard deviation. It's used for testing hypotheses and is not useful for estimation. This test can also be applied to a complex contingency table with several classes and as such is very useful in research work. The test is an important non-parametric test as no rigid assumptions are necessary in regard to the type of population. No need of parameter values and relatively less mathematical details are required. Important terms that we should know are, first of all, what is a parametric test? The test in which population constants like mean, standard deviation, standard error, correlation coefficient, proportion, etc., and other data tend to follow one assumed or established distribution such as normal, binomial, and Poisson, etc. Non-parametric test, on the other hand, is a test in which no constant of population is used. Data does not follow any specific distribution and no assumptions are made in this test. For example, to classify good, better, and best, we just allocate arbitrary numbers or mark to each category. Hypothesis. This is basically a definite statement about the population parameters. What is the null hypothesis? This basically states that no association exists between the cross-tabulated variables in the population and therefore the variables are statistically independent. Example, if we want to compare two methods, method A and method B for superiority, and if the assumption is that both are equally good, then this assumption is known as the null hypothesis. Alternative hypothesis proposes that the two variables are related in the population. If we assume that from the two methods, method A is superior than B, then this assumption is known as the alternative hypothesis. Degrees of freedom. This basically denotes the extent of independence freedom enjoyed by a given set of observed frequencies. Suppose we are given a set of n observed frequencies which are subjected to k independent constraints, that is restrictions, then the degree of freedoms is going to equal to the number of frequency minus the number of independent constraints on them. In other terms, df equals to r minus 1 into c minus 1, where r is the number of rows and c is the number of columns. What is the contingency table? When the table is prepared by enumeration of qualitative data by entering the actual frequencies, and if that table represents occurrence of two sets of events, that table is called the contingency table. It is also called an association table. Chi-square distribution. When we consider the null speculation is true, the sampling distribution of the test statistic is called the chi-square distribution. The chi-square test helps to determine whether there is a notable difference between the normal frequencies and the observed frequencies in one or more class or categories. It gives the probability of independent variables. Note that the chi-square test is applicable only for categorical data, such as men and women falling under the categories of age, gender, height, etc. Now finding the P-value. P basically stands for probability here. And to calculate the P-value, the chi-square test is used in statistics. The different values of P are going to indicate the different hypotheses and their interpretation. If the value is less than or greater than 0.05, the hypothesis is rejected. If it is greater than 0.05, the hypothesis is accepted. Probability is all about chance or risk or uncertainty. It is the possibility of the outcome of the sample or the occurrence of an event. But when we talk about statistics, it is more important, it is more how we handle the various data using different techniques. It helps to represent complicated data or bulk data in a very easy and understandable way. It describes the collection, analysis, interpretation, presentation, and organization of data. The concept of both probability and statistics is related to the chi-square test. Properties. The following are important properties of the chi-square test. 2 times the number of degrees of freedom is equal to variance. The number of the degree of freedom is equal to the mean distribution. The chi-square distribution curve approaches the normal distribution when the degrees of freedom increases. The formula. The chi-square test is done to check if there is any difference between the observed value and the expected value, and the formula can be written as such, which is basically observed minus expected value square over the expected value. How to perform basically chi-square test by hand, step by step. A chi-square goodness of test is used to determine whether or not a categorical variable follows a hypothesized distribution. The following step-by-step example is going to show you how to perform it by hand. Chi-square goodness of fit test by hand. We start off by supposing that if we believe a certain dice is fair, in other words, that means that the dice is equally going to land on a 1, 2, 3, 4, 5, 6 on a given roll. To test this, we will roll it 60 times and record the number it lands on each time, and the results are as follows. The first time it lands 8 times, second time 12 times, third 18 times 4, 9 times 5, 7 times, and 6 times. Using the following steps to perform a chi-square goodness of fit test in order to determine if the dice is fair or not. Step 1. First of all, defining the null and alternative hypotheses. So the null hypothesis is that the dice is likely to land on each number, and the alternative hypothesis is that the dice is not likely to land on each number. Step 2, we calculate the observed and expected frequencies. For this, we're going to create a table of the observed and expected frequencies for each number of the dice, and you can see this as follows. Step note, if we believe the dice is fair, this means we expect it to land on each number an equal amount of times, in this case 10 times. So step 3 is we calculate the test statistic, and this is calculated by the formula I showed you guys earlier, which was observed minus expected over the expected values, and the following table is basically shows you how these values have been calculated, and then when you add them up, this is as shown. In this case, it turns out to be 9.8. Then step 4 is going to be that we find the critical value. In order to find the critical value in the chi-square distribution table, that's going to correspond to 0.05, and the degrees of freedom that is in the categories 1. In this case, there are 6 categories, so we will minus 6 by 1, and we can see that the critical value is going to be 11.07 from this table. As you can see here, the 11.07 corresponds to 5 degrees of freedom. Step 5, which is basically whether or not to reject or accept the null hypothesis. Since our statistic is less than the critical value, we fail to reject the null hypothesis. This means we do not have sufficient evidence to say that the dice is unfair. Why do we use the chi-square test? The chi-square test is a statistical test that examines the differences between categorical variables from a random sample in order to determine whether the expected and observed tests are well-fitting. Some of the uses of chi-square tests are that they can be used to see if your data follows a well-known theoretical probability distribution like the normal or Poisson distribution. The chi-square test allows you to assess your trained regression model's goodness of fit on training, validation, and test data sets. What does basically chi-square statistic test tell you? It is fundamentally a data analysis based on the observations of a random set of variables. It computes how a model equates to the actual observed data. A chi-square statistic test is calculated based on the data, which must be raw, random, drawn from independent variables, drawn from a wide-ranging sample, and must be mutually exclusive. In simple terms, two sets of statistical data are compared, for instance, the results of tossing a fair coin. Carl Pearson introduced this test in the 1900s for categorical data analysis and distribution, and it is also known as the Pearson's chi-square test. Chi-square tests are most commonly used in hypothesis testing. A hypothesis is an assumption that a given condition might be true, which can be tested afterwards. The chi-square test estimates the size of inconsistency between the expected results and the actual results when the size of a sample and number of variables in the relationship are mentioned. This test uses the degree of freedom to determine if a particular null hypothesis can be rejected based on the total number of observations made in the experiment. Larger the sample, the more reliable is the result. The two main types of chi-square tests are independence and goodness of fit. Independence. The chi-square test of independence is derivable, also known as inferential statistic test, which examines whether the two sets of variables are likely to be related with each other or not. This test is used when we have counts of values for two nominal or categorical variables and is considered as a non-parametric test. A relatively large sample size and the independence of observations are the required criteria for conducting this test. An example is that in a movie theater, suppose we made a list of movie genres. Let us calculate this as the first variable. The second variable is whether the people who came to watch those genres of movies have bought snacks at the theater. Here, the null hypothesis is the genre of the film, and whether the people bought snacks or not are unrelatable. If this is true, then the movie genres aren't going to impact snack sales. Goodness of fit. In statistical hypothesis testing, the chi-square goodness of fit test determines whether a variable is likely to come from a given distribution or not. We must have a set of data values and the idea of distribution of this data. We can use this test when we have value counts for categorical variables. This test demonstrates a way of deciding if the data values have a good enough fit for our idea or if it is representative sample data of the entire population. For example, suppose we have a bag of balls with different colors in each bag. The given condition is that the bag should contain equal number of balls of each color. The idea we would like to test here is the proportions of the 5 colors the balls in each bag must be exact. Who basically uses chi-square analysis? Chi-square is mostly used by researchers who are studying survey response data because it applies to categorical variables. Demography, consumer and marketing research, political science, and economics are all examples of this type of research. Example, let's say you want to know if a gender has anything to do with political party preference. You poll 440 voters in a simple random sample to find out which political party they prefer. The results of the survey are shown in the table below. You can see Republican, Democrat, Independent, the male, female, and then the total voters. To see if the gender is linked to political party preference, we will perform a chi-square test of independence using the steps below. Step 1. You define the hypothesis. The null hypothesis is that there is no link between gender and political party preference. Alternative one is that there is a link between the gender and political party preference. Step 2, we calculate the expected values. Now, basically that's done by the row total into the column total over the total number of observations. And the expected value for male Republicans is 240 into 200 over 440. So the answer is 109. And similarly, we calculate the expected value for each of the cells. You can see it is done over here. Now you will calculate the chi-square value, which is observed minus expected square over the expected value. And this can be seen done in the table, which is shown. Step 4, we calculate the test statistic. This is basically going to be the sum of all the values in the last table. Before you can conclude, you must first determine the critical statistic, which requires determining our degrees of freedom. The degrees of freedom in this case are equal to the table's number of columns minus 1 multiplied by the table's number of rows minus 1, which is R minus 1 into C minus 1. Therefore, we get the value 2. Finally, you compare our obtained statistic to the critical statistic found in the chi-square table. As you can see, for an alpha level of 0.05 and 2 degrees of freedom, the critical statistic is 5.991, which is less than our obtained statistic of 9.83. Therefore, we can reject our null hypotheses because the critical statistic is higher than your observed statistic. This means you have sufficient evidence to say that there is association between gender and political party preference. This was calculated from this table. The critical values of the chi-square distribution with d degrees of freedom. When to use a chi-square test? A chi-square test is used to examine whether the observed results are in order with the expected values. When the data to be analyzed is from a random sample, and when the variable is a categorical variable, then chi-square proves the most appropriate test for the same. A categorical variable consists of selections such as breeds of dogs, types of cars, genres of movies, educational attainment. Survey responses and questionnaires are the primary sources for this type of data. The chi-square test is most commonly used for analyzing this kind of data. The type of analysis is helpful for researchers who are studying survey response data. The research can range from customer and marketing research to political science and economics. Chi-square distribution. In statistical analysis, the chi-square distribution is used in many hypothesis tests and determines the parameter, the degrees of freedom. It belongs to a family of continuous probability distribution. The sum of the squares of the k-independent standard variables is called the chi-square distribution. The shape of the distribution graph changes with an increase in the value of k, that is the degrees of freedom. When k is 1 or 2, the chi-square distribution test is going to be shaped backwards in the form of a j. This means that there's a high chance that the chi-square value is going to become close to 0. When k is greater than 2, the shape of the distribution curve looks like a hump and has a low probability that it is going to be very near to 0 or very far from 0. The distribution occurs much longer on the right-hand side and shorter on the left-hand side. The value is going to be -2. And you can see the graph when k is greater than 90, normal distribution is going to be seen approximating the chi-square distribution. What is a good value of the chi-square? What is a good chi-square value? 5 is assumed to be a good chi-square value, and for a chi-square value to be valid, at least 5 must be the expected frequency. Limitations of the chi-square test. There are 2 limitations to using a chi-square test that you should be aware of. The chi-square test, for starters, is extremely sensitive to sample size. Even significant relationships can appear statistically significant when a large enough sample is used. Keeping in mind that the statistically significant does not always imply meaningful when using a chi-square test. Be mindful that the chi-square test can only determine whether 2 variables are related. It does not necessarily follow that one variable has a causal relationship with the other. It would require more detailed analysis to establish causality. Now, recent advances. The chi-square test of independence. The chi-square test is a non-parametric distribution-free tool designed to analyze different groups when the dependent variable is measured at a nominal level. Like all non-parametric statistics, the chi-square is robust with respect to the distribution of data. Specifically, it does not require equality of variances among the study groups or homostaticity in the data. It permits evaluation of both dichotomous independent variables and to multiple group studies. Unlike many other non-parametric and some parametric statistics, the calculations need to compute the parametric statistics calculation need to compute the chi-square provide considerable information about how each of the groups performed in the study. This richness of detail allows researchers to understand the results and thus derive more detailed information from the statistic rather than many others. The chi-square is a significant statistic and should be followed with strength statistic. The Cramer's 5 is the most common strength test used to test the data when significant chi-square result has been obtained. Advantages of the chi-square test include its robustness with respect to distribution of data, its ease of commutation, the detailed information which can be derived from the test, its use in studies for which parametric assumptions cannot be met, and its flexibility in handling data from both groups and multiple group studies. Limitations include its sample size requirements, difficulty of interpretation when there are large numbers of categories and the independent or dependent variables, and tendency of Cramer's 5 to produce relative low correlation measures even for highly significant results. A new association test based on chi-square partition for case-controlled GWA studies. In case-controlled genetic association studies, the robust procedure Pearson chi-square test is commonly used for testing association between disease status and genetic markers. However, this test does not take the possible trend of relative risks which are due to genotype into account. On the contrary, although Cochrane-Armitage trend test with optimal scores is more powerful, it is usually difficult to assign the correct scores in advance since the true genetic model is rarely known in practice. If the unknown underlying genetic models are misspecified, the trend test may lose power dramatically. Therefore, it is desirable to find a powerful yet robust statistical test for genome-wide association studies. In this paper, we propose a new test based on the partition of Pearson's chi-square test statistic. This new test utilizes information of the monotonic trend of relative risks and therefore in general is more powerful than the chi-square test. Furthermore, to reserve the robustness using simulated and real single nucleotide polymorphism data, we compare the performance of proposed tests with existing methods. Now coming to MCQs. MCQ number 1. Which of the following distributions is best used for testing hypotheses? Option A, normal distribution. Option B, chi-square distribution. C, gamma distribution. D, Poisson distribution. Or E, z-test.
Alpha.
No, the answer is B, which is the chi-square distribution. Question number 2. The null hypothesis in the chi-square test states that A, the rows and columns in the table are associated. The rows and columns in the table are not associated. C, null hypothesis isn't used in the chi-square test. D, none of the above. Or E, all of the above.
C.
No,
Charlie?
B, it's B. Question number 3. The parameter of chi-square distribution is A, number of rows, B, degrees of freedom, C, number of columns, D, number of cells, or E, number of squares.
B.
Yes.
B.
Yeah, that's right. 4. The range of chi-square is A, 0 to infinity, B, -1 to 1, C, minus infinity to 0, D, minus infinity to infinity, and E, which is 1 to 100.
E.
No, the answer is 4A. For an R into C contingency table, the chi-square test has degrees of freedom, which are going to be represented by which of the formula? A, R minus 1 plus C minus 1. R represents the row, C represents the column. B, which is just R minus 1. C is R into C. D is R minus 1 into C minus 1. Or E, CR.
A.
No, this is D.
Charlie? Oh.
It's D because you multiply R minus 1 into C minus 1. 6. A TV enthusiast would like to know if a set of television shows that were nominated for an Emmy were likely to come from ABC, CBS, NBC, and Fox. What test asks whether the number of nominations from each network are consistent with the population distribution in which 1/4 of the nominations were from each network? A, two-sample t-test for difference in means. B, one-factor analysis of variance ANOVA. C, two-factor analysis of variance ANOVA. D, chi-square test for goodness of fit. Or E, z-test.
D.
B.
Yes, the answer is D. 7. The shape of the chi-square distribution is A, left-skewed, B, right-skewed, C, unimodal and symmetric, D, bimodal and symmetric, or E, trimodal and symmetric.
C.
B.
Charlie?
It's B.
B.
Yeah. 8. What must be true about the expected values in a chi-square test? A, greater than or equal to 2, B, greater than or equal to 5, greater than or equal to 10, D, greater than or equal to 30, or greater than or equal to 100.
B.
Yes, B is the right answer. 9. In a chi-square goodness of fit test, you must have A. Expected counts for 2 samples, B. Observed proportions for 1 categorical variable, C. Observed counts for 1 categorical variable, D. Observed proportions for 2 categorical variables, or E. All of the above.
D.
C.
Yes, the answer is C. Okay, so recent revenue shortfalls in Midwestern state led to a reduction in the state budget for higher education. To offset the reduction, the largest state university proposed a 25% tuition increase. It was determined that such an increase was needed simply to compensate for the loss of support of the state. Separate random samples of 50 freshmen, 50 sophomores, 50 juniors, and 50 seniors from the university were asked whether they were strongly opposed to the increase, given that it was a minimum increase necessary to maintain the university's budget at current levels. The results in the table are provided. Which hypotheses would be appropriate for performing the chi-square test? So this is the table, and it basically shows the number of freshmen, sophomore, juniors, seniors per year, which who are basically strongly opposed per year. So you can see the yes number and the no number. The options are, which were basically the options to see which hypothesis is appropriate for performing the chi-square test. A, the null hypothesis is that the closer the students get to graduation, the less likely they are to be opposed to tuition fees. The alternative is that how close students are to graduation makes no difference in their opinion. This is option A. Option B is that the null hypothesis is that the mean number of students who are strongly opposed is the same number for each of the 4 years. And the alternative hypothesis is that the mean is different for at least 2 of the 4 years. Option C is that the null hypothesis is that the distribution of student opinion about the proposed tuition increase is the same for each of the 4 years of university. And the alternative is that the distribution is different for at least 2 of the 4 years. Option D. The null hypothesis is that the year in the school and the student opinion about tuition increase in the sample are independent. The alternative is that these variables are dependent. And E, all of the above can be applied.
D.
C.
The answer is going to be a C, sorry. This is basically our
Okay,
key.
thank you very much. Yes, this is the key. And as we are ending towards the presentation, it is a good presentation, especially the recent advances part that was very nicely done. There were graphs in the presentation. However, there are 2 things that I must emphasize. First is there must be more graphs and pictures and data in the presentation so that everyone can have a very interesting interaction with the different figures and summarization measures. The second important thing is in MCQs, we have decided in the pattern that all the MCQs must be scenario based, and there should be no option that is all of the above, none of the above. So with these 2 observations, I think that overall it is a very good presentation, very well done. Please share the slides after these corrections. Thank you very much. Allah Hafiz.
Thank you, Allah.
Allah Hafiz.